Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 6 in the authentication module titled Broken Brute Force Protection IP Block. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy, select all labs, do a search on authentication vulnerabilities, and select lab number 6 titled Broken Brute Force Protection IP Block. Alright, let's get started. This lab is vulnerable due to a logic flaw in its password brute force protection. To solve the lab, brute force the victim's password, then log in and access their account page. And then they give you a regular user credentials. You've got the victim's username, which is Carlos, and then you also have a candidate passwords list. Alright, so the target goal over here is to exploit the logic flaw in the password brute force protection mechanism and brute force Carlos's password. Alright, let's access the lab. Now notice over here, this is the built-in browser in Burp, and so all my requests are already being passed in my Burp proxy. I am using the professional version of Burp because we will require the intruder functionality, which is heavily throttled in the community edition. Alright, so let's click on my account. And then let's say Carlos and put in a random password, hit login. This is the post request that is performed. Let's send it to repeater. Hit send again. So this is the second time. Let's render. It says incorrect password. Hit send again. It says incorrect password. So this is, by the way, vulnerability number 1, the fact that there's a verbose error message that tells you whether the username is incorrect or the password is incorrect, which allows me to enumerate valid usernames in the application. So let's hit it one more time. So that's the third one. And you could see over here, it says you have made too many incorrect login attempts. Please try again in 1 minute. And so after 2 or 3 attempts, it provides you with a soft lockout in order to prevent brute force. Now let's see what happens when we log in with an account that we do have. So our regular account, the password was Peter, hit send. It says that you have made too many incorrect login attempts. Please try and log in again. Okay, so let's wait this 1 minute and then try one more thing. And we're back. 1 minute should have passed by. So what I'm going to try right now is I'm going to try 2 incorrect attempts. And then I'm going to try a correct attempt after that. So instead of a third incorrect attempt, I'm going to try a correct attempt on the third time and see if the counter resets in the back end. If it does reset, then what that means is for our attack, we can have a list of usernames and passwords to try, but we can only try them 2 at a time. And after every 2 attempts, we're going to have to log in with a valid username and password. So let's try that right now. So let's say Carlos. Hit send. Incorrect password, so that's attempt number 1. Attempt number 2. Now I'm going to log in with the regular credentials on attempt number 3. Okay, follow redirection, and you could see over here it says it leads me back to the login page, but it actually properly logged in as a user. So let's go back and now try attempt number 4. That is incorrect for Carlos. Hit send. Incorrect password. Hit send again. I should have been logged out right now, but it looks like because I did log in with a valid username and password, it reset the counter in the backend, and so it allowed me 2 more tries. So every time we try 2 incorrect password attempts, we need a correct login attempt in order to try 2 more incorrect password attempts. And so I'm not sure we could do all of this in Burp. We actually might have to script a portion of this exercise. So what we're going to do is we're going to go to proxy and actually go to repeater. Just send this to intruder. In intruder over here, let's clear. And the only thing that we're brute forcing is the password. So hit add, and in payloads over here, we need the candidate list. So if we right click and open it in a new tab, this is the list of passwords that we want to attempt to brute force. again, if we try 3 incorrect attempts, we get throttled for 1 minute, and then it's going to take an unbelievably long amount of time to go through this entire list over here. And so what we're going to do is we're going to make sure that after every 2 attempts over here, it logs in with the regular account credentials that we were given. So it would be a correct attempt, and then it'll try another 2 attempts, and so on. And so to do that, we will require some Python scripting. So the first thing that I've got over here, I've got the passwords.txt list right over here. And what I'm going to do is I've got a Python script as well that I'm going to write that will add the credentials of our regular user after each 2 passwords over here. So we'll add a credential right over here, we'll add the credential right over here, we'll add the credential right over here, and so on. So let's do that. So the first thing I'm going to do is print the following are the usernames. So in order to brute force this as well, we also need a list of usernames. So for this one, we're trying it on Carlos. For this one, we're trying it on Carlos. And then for the third attempt, we're trying it on our regular user. And so I'm going to say for I in range, I believe we might have 100 passwords over here, and then if we need to put our regular user's password after every 2 attempts, then we'll need 150 entries. So we'll say 150, and this will make sense once we complete the exploit. So if I modulus 3, so every 3 times add in our regular user, otherwise add in the Carlos user. So else add in our regular user. So essentially what this will do is it'll print Carlos, Carlos, our regular user, Carlos, Carlos, our regular user, Carlos, Carlos, our regular user, and so on. And then we need a matching password list. So we're going to print the following are the passwords. And for that, we're going to open the file of passwords that I saved before this exercise. So passwords.txt. And we're reading that, and let's say as f, and then lines is equal to f.readLines. So we're just reading all the passwords in that file. And then from there, we're going to set a counter, I to 0. And then we're going to say for each password in lines, again, if I modulus 3, then print the password itself. So dot strip the new line from the password. So we just want the password. Otherwise, print Peter. So that's the password of our regular user. And then print password dot strip the new line. And then we're going to increase our counter. I is equal to I plus 1. And we also increase that counter over here. I is equal to I plus 1. Okay, so essentially what this script is going to do, if we go back to our notes document, is it'll generate 2 lists. The first list is the list of usernames, so that would be Carlos, Carlos, our regular account, Carlos, Carlos, and so on. And then it'll go through this password list and it'll print the password list. So we'll have another list over here. It'll take each 2 passwords, and after every 2 passwords, it'll print our regular account's password, and then it'll move on to the next 2 passwords, and so on. And so when we put this list in Intruder, we'll bypass the brute forcing mechanism, because after every 2 incorrect attempts, we're logging in with a correct attempt, and so we're resetting the counter, which allows us to brute force it without having the soft lockout mechanism that will increase the amount of time that we need to brute force the attack. All right. So let's save this. Hopefully there's no errors, and I'm already noticing an error over here. Let's save it again. Go to terminal, new terminal, Python 3 and authentication lab 6, usernames.py, hit enter, and I do have an error. So if we go down right over here, It's on line number 19. And this should be strip, not string. Let's save it, clear again, run it one more time, and here we go. So here's my list. We've got the list of usernames and the list of passwords, so we're ready to use Burp Intruder to brute force our attack. So let's hit send over here, and the lab is still up and running. We won't have to open a new instance. And in the payload list over here, so if we go to positions, we only have one position, but we need 2 positions. So the first one is the list of usernames, so let's copy that. Go to payloads and paste it in here. And then the second one is the list of passwords. So if we go back to positions and say that this is Pitchfork, because the way Pitchfork works is it'll try the first entry in the first list and the first entry in the second list, and then it'll move on to the second entry in the first list and the second entry in the second list, and so on. And so we needed to try them together. So the second list over here is this one right over here. Let's copy it, paste it. And I'm noticing right now there's probably an easier way of doing this using macros in Burp, but this way works as well. So hit start attack. And over here, I see a 302 on our regular user, but I'm looking for a 302 on the Carlos user. Okay, so let's do a search on status. And so far we haven't gotten one for Carlos, which is a little bit concerning. So that means our exploit did not work. I'm wondering if I did get locked out. So let's render. So incorrect password. And I am getting locked out, so I've done this incorrectly. And I know what the issue is, so okay. This is bad on my part, but if you go to resource pool over here, it does 10 maximum concurrent requests at a time. And we needed to do 1 request at a time, or else it's doing 10 requests at the same time. And so of course we're getting logged out. So let's discard this whole thing. Go back to intruder, go to resource pool, and then create a new resource pool and say maximum concurrent request is 1. And then we're gonna have to wait another minute until we start the attack to ensure that the lockout is not in effect. And then when we click on start the attack, since it does 1 concurrent request at a time, we should be okay and we should be able to complete the lab. Okay, 1 minute should have passed by. Let's click on start attack, and hopefully this is the last time we have to do this. So let's confirm we're not getting the lockout screen. So far so good. Okay, so I'm confident with this because you could see over here we're not getting the lockout screen anymore, and the reason was because before we were using concurrent requests, now we're not. So what I'm looking for is a 302 but on the Carlos's account. And you could see over here we actually do have one for Carlos, but let's just wait for the entire thing to complete and then we'll look at Carlos's account. All right, it completed. Let's do a sort again to look for a 302 on Carlos's account. Now for our regular account, we expect a 302 because we know for sure that the credentials are correct, but we're looking for Carlos. And here we go. So the username is Carlos and the password is Matthew or Matthew, whatever correct way it's said. So let's put in Carlos over here and Matthew, hit login. And here we go. It says congratulations, you solved the lab. All right, so we successfully completed the exercise by exploiting the vulnerability using Intruder and a Python script. In the next lab, we'll look at another case of a broken authentication vulnerability.